Now the first term is mole. How to define mole? Atomic mass, molecular mass, or the formula mass of the substance which is expressed in grams is referred as 1 mole, right? Similarly, we say atomic mass, molecular mass, or the formula mass of a substance, or the ionic mass of the substance when there are ions present in it, in grams, that contains 6.02 10 power 23 particles in it, that is termed as 1 mole of the substance. Here some examples are given which will give you the clarity of the concept that what is mole. If we say 1 atom of carbon, that will be equal to 1 mole of carbon and it will carry mass 12 grams. If we say 1 atom of magnesium, so it is equal to 1 mole of magnesium and it will carry the mass 24 grams. For carbon dioxide, 1 molecule of carbon dioxide is equal to 1 mole and it will carry mass 44 grams. Similarly, 1 molecule of water is equal to 1 mole and it will carry the mass 18 grams. Right? When we say formula unit, NaCl or sodium chloride, the one formula unit of sodium chloride is equal to 1 mole and it is carrying mass 58.5 grams. Right? Now, how to calculate mole? Here the formula is mentioned. I hope you people are familiar with it. It is given, that is mole is equal to given mass upon molar mass of the substance. Now this molar mass can be in the form of atomic mass, molecular mass, formula mass, or the ionic mass of the substance. Here, for example, if we say the how many moles are present in 10 grams of water, so we will apply the formula, that is 10 upon 18 given mass over molar mass equal to 0.556 moles. It will carry 0.556 moles in it. Right, Ji? This is the way how to calculate moles. Again, then we say ionic mass, if we say about, then how to explain it? Or we say 1 mole of sodium chloride, if it is being asked as a short question, that 1 mole of sodium chloride contains 2 moles of ions, then how you will justify it? Now here an equation is given for this 1 mole of NaCl. NaCl is an ionic compound and you know very well ionic compounds are formed of aggregates of ions. When sodium chloride is dissolved in water, it is going to generate sodium ions and chloride ions. In total, one formula unit, that is 1 mole of NaCl, is producing 2 moles of ions. How? That is 1 mole of sodium ion plus 1 mole of chloride ion means equal to 2 moles of ions. Right? And if we say how many cations are produced from 1 mole of NaCl, or you say how many moles of anions are produced by the dissociation of 1 mole of NaCl, what will you say? It means we have to say that 1 mole of NaCl, when it will dissociate, it will produce 1 mole of cations, that is of sodium ions. I hope you know what are cations. Positively charged ions are called cations, right? And it will also produce 1 mole of chloride ions. I hope you know what are anions. Chloride is an anion as it carry a negative charge on it. So this is how the formula unit, 1 mole of formula unit of NaCl will generate 2 moles of ions in water. Right? This is to explain that 1 mole of NaCl will produce 2 moles of the ions. This is the answer. Okay. Now students, I hope you are familiar with Avogadro's number. Avogadro's number is represented by an A. In your book, it is also termed as representative particles. How to define it? The number of atoms, ions, or molecules present in 1 mole of the substance is termed as Avogadro's number. The numerical value of this Avogadro's number is 6.02 into 10 to the power 23. 1 mole of any substance at STP, it carries the number of atoms or the molecules or the formula units or ions that is equal to 6.02 10 to the power 23. Right now, how to use this term in equations? So look at this equation which is mentioned here, that 2 moles of hydrogen reacts with 1 mole of oxygen to produce 2 moles of water. Now, in terms of Avogadro's number, what will you say? You will say 1 mole equal to 6.02. So 2 moles will be equal to 2 into 6.0 10 to the power 23 particles. Okay. Now here we will say 6.02 into 10 to the power 23 multiplied by 2 molecules of hydrogen reacts with 6.02 into 10 to the power 23 molecules of oxygen to produce, here again we have the prefix 2 in this formula, that is 2H2. So we will say in product side there are present 2 into 6.02 into 10 to the power 23 molecules of water. Right? Now this is what we say. We have explained this equation in terms of Avogadro's number. Again we will say 2 into 6.02 into 10 to the power 23 molecules of hydrogen reacts with 1 mole, that is 6.02 into 10 to the power 23 molecules of oxygen to produce 2 into 6.02 into 10 to the power 23 molecules of water. Clear? Now, how to calculate it? What the mole? How to calculate the number of moles of a substance? An equation is mentioned here. Number of moles of a substance is equal to number of molecules of a substance divided by Avogadro's number. Right? Now, this Avogadro's number can be given as 6.0 10 to the power 23 particles. Okay. Now students, this slide is defining you how the mole ratios are used as conversion factors in stoichiometric calculations. What does it mean? Right? The mole ratio is as its definition and its use in the stoichiometric calculation, or the relation with the stoichiometric calculation is mentioned here. The mole ratio is the ratio of the number of reactants taking part in a chemical reaction and the number of products being formed. Right? Similarly, what the balanced equation tells you about the mole ratios. Here we have a balanced chemical equation indicates the number of moles and amounts of substances which are taking part in a reaction and being formed as a product. How to use this information? By using this information, you can interpret or find out the how much quantity will you require to form a desired one amount of the product. How much amount of the reactants will be taken to get a desired amount of the product. Right? So this is all about what we say mole ratios are. Just apply it on this equation that is mentioned below. This equation gives you the combustion of propane. The molar formula or molecular formula of propane is C3H8. 1 mole, according to the equation, 1 mole of this C3H8, that is propane, reacts with 5 moles of oxygen to generate 3 moles of carbon dioxide and 4 moles of water, right? Now this equation is giving you the mole ratio amount. If we say make a mole ratio between the propane and carbon dioxide, so we'll say the relationship between two is 1 mole of propane is producing 3 moles of carbon dioxide. Is it? Or if we relate oxygen to carbon dioxide, what will we say? 5 moles of oxygen are generating 3 moles of carbon dioxide. This is what we say is the mole ratio. Ratio between reactant and product, or this can be the ratio between reactant to reactant. For example, once again, if we say according to this equation, 1 mole of propane requires 5 moles of oxygen, right, in this balanced chemical equation to get the product. So if we are going to make use of 2 moles of C3H8, how many moles of oxygen will be required? Ultimately, the answer should be 10. This is how the mole ratio given in the equation is used to predict the next answer, that how much quantity will be generated or how many moles of the substance will be produced or will react if the other substance amount is being changed. Right, Ji? Now this slide is giving you the construction of mole ratios as conversion factors in stoichiometric calculations. Once again, what is meant by the mole ratio? Mole ratio is the ratio between number of moles of reactants to the number of moles of the product. According to this equation, if we relate one of the reactant to the product, we will say, for example, hydrogen. So you will say 2 moles of hydrogen is producing 2 moles of water, right? This will give you the conversion factor, right, G? Now here we have, if you are given the question that if you are provided 4 moles of H2, then how many moles of water will be produced? So what you have to do? According to this equation, the conversion factor or the mole ratio will be 2 upon 2, right? That is 2 moles of water upon 2 moles of hydrogen. And if you have 4 moles of hydrogen, so what will be the amount of water? Right, Ji? This is what we say is the conversion factor. This one, the substance, the moles of which are required by the moles of the substance which is given in extra amount, right? Uh, what is meant by the conversion factor? The conversion factor is the ratio of coefficients in a balanced chemical equation which can be used to interconvert the amounts of any two participants, right? This one, which I have presented here from the above equation, I will write a conversion factor for this equation as mole of required substance. As I said, I need the moles of water. How many will be produced if I use 4 moles of hydrogen? So I will relate the moles of hydrogen and water in this balanced chemical equation first. So I will write 2 upon 2. This is the conversion factor from this balanced chemical equation, right? This is called mole ratio or conversion factor. Now, how to use it in calculation? Desired quantity of the substance, that is how many moles of water will be produced. Given quantity of this hydrogen, that how much is being given. As I told you earlier, suppose 4 moles are given of it, multiplied by conversion factor is 2 upon 2, which is generated from the balanced chemical equation, right? So this will give you the desired quantity, that 4 moles of water will be produced when we will use 4 moles of hydrogen, right Ji? This is what we say to construct mole ratios used in the stoichiometric calculations. This sample problem is given in your book and we are going to discuss it to get what the use of mole ratios is in stoichiometric calculation. Here an equation is given. Methanol burns according to the equation. Methanol is C3OH, it is an alcohol. According to this equation, 2 moles of methanol reacts with 3 moles of oxygen to produce 2 moles of carbon dioxide and 4 moles of water. Now this is what we have come to know from that of the equation. Now if the 3.50 moles of methanol are burned in oxygen, then we have to calculate. Now the part A is how many moles of oxygen are used, right? Now in this A part, we have to construct a mole ratio or a conversion factor by using both the reactants, that moles of alcohol and moles of oxygen from the balanced chemical equation will give you the construction of mole ratio. As the quantity of oxygen or the moles of oxygen are asked, are required, right? So we have to write 3 moles of oxygen in equation as numerator and 2 moles of methanol from this balanced chemical equation as denominator to write the mole ratio or the conversion factor. So it will be 3 upon 2. Now the formula is desired quantity of oxygen is equal to given quantity. Given quantity of what? Given quantity of methanol, that is 3.50, multiplied by conversion factor as you have taken it out from the balanced chemical equation. So it will be 3.50 moles of methanol multiplied by 3 upon 2, right? So it will give you 5.25 moles of oxygen. Okay, now the second part is B part. How many moles of water are produced? Again, we are given the quantity or the moles of methanol. So we have to make use of a mole ratio in between methanol and water. Right, now how to construct the conversion factor from this equation for these two regions? Here we have 2 moles of methanol which produces 4 moles of water from this balanced chemical equation. We need moles of water to be produced from 3.50 moles of methanol. So the conversion factor from the given equation will be 4 moles of water will be written as numerator from the equation and 2 moles of alcohol or methanol will be written as denominator to give you the conversion factor or the mole ratio, right? Means 4 upon 2 is the conversion factor for this water molecule to be produced, right, from given quantity. Okay, now then what you have to do, again apply the formula. Desired quantity is required of water, that how much it will be produced. Now here the formula is given to find out the desired quantity of water molecules, as it is given that the given quantity of moles of CH3OH is 3.50 multiplied by conversion factor, and the conversion factor is 4 upon 2, that is the amount of which substance is required divided by the given amount of the substance from the balanced chemical equation. So we get there 3.50 multiplied by 4 upon 2 moles of water. So it will give you 7 moles of water, which will be your answer. This is how to use mole ratios in stoichiometric calculations. Remember it, and when we are doing stoichiometric calculations, the no side products, or we say the law of conservation of mass is applied here, and none of the thing is lost or neither is being new created, but the mass remains same on both the sides. Right, G? Now, a self check is mentioned here. The self check is taken again from your book. Ammonia is the raw material in the manufacture of the fertilizers. It is obtained by the combination of nitrogen and hydrogen, like this. This is the equation mentioned here. Now, how to read this equation? We will say 1 mole of nitrogen reacts with 3 moles of hydrogen to produce 2 moles of ammonia. Now, the question is, how many molecules of the following are required to manufacture 5 moles of ammonia? The given quantity is of ammonia, 5 moles. 1 mole of ammonia is from equation, that is 2, which will help in the formation of conversion factor, which will be taken in denominator. The other quantity which is given, that is 5 moles, to which we have to relate it with the nitrogen and hydrogen in the equation, right? So first of all, for nitrogen, how to construct the conversion factor in it? The conversion factor of nitrogen for the quantity of the nitrogen will be 1 upon 2. Now here we have, this one is the conversion factor for nitrogen, as 1 mole of nitrogen is present as a numerator given by divided by the denominator, that is 2 from the balanced chemical equation of ammonia. Now how much or how many moles of ammonia are given, right, for the manufacturing process? Here we have 5 moles of it. So moles of ammonia which require nitrogen to be produced, that is 5 into 1 upon 2 moles of nitrogen. It will give you 2.5 moles of nitrogen will give or will produce 5 moles of ammonia. Similarly, for equation for the hydrogen, the conversion factor will be 3 upon 2, right, multiplied by 5 will give you 7.5 moles of hydrogen are required to manufacture 5 moles of ammonia. I hope you understand the use of the mole factors or the mole ratios and the conversion factors in the equation. The last term is volume of gases, which is applicable only when the medium is in the gaseous form, or the gases are used as reactants and products. Here the relationship between volume of gases in the chemical equation is defined by Gay-Lussac's law of combining volumes. According to this law, gases reacts in a simple whole number ratios. The standard temperature and pressure is applied, or the gases react or they formed in the ratio of small whole number ratios by volume measured under the same conditions of temperature and pressure. Here the standard one volume that is taken at STP is 22.414 dm cube, that is decimeter cube, which is the standard one condition, right? Now how to apply it in equations? Here we say H2 reacts with Cl2 to produce 2HCl. Here you will find the term G is mentioned in a parenthesis. This G represents the state of the substance, right? Now according to the equation, you will say 1 volume of hydrogen, not a fraction you have to use, but the whole number we have to use in the equation. 1 volume of hydrogen reacts with 1 volume of chlorine to produce 2 volume of HCl. And if I use the term 22.414 dm cube as a standard, which is taken at STP. Now what STP stands for? STP is standard temperature and pressure. Standard temperature is considered as 0 degree centigrades and the pressure is considered as 1 atmospheric pressure, right, or 760 millimeter Hg. Now here we have 22.414 dm cube of hydrogen, which is the uh, volume of 1 mole of hydrogen gas, reacts with 22.414 dm cube of Cl2 to produce 2 into 22.414 dm cube of HCl, right? Now here there is given a relation between volume and the Avogadro's law, how to use it. Now the relationship between them is 1 mole of any gas at STP has a volume 22.414 dm cube, as I told you earlier, 22.414 dm cube, right? This is called the molar volume. STP means, as I told you earlier, what is the relation between volume, Avogadro's number, and mole. So here we have 1 mole of any gas is equal to 6.0 10 to the power 23 atoms or the molecules, and it carry the volume 22.414 dm cube, that is at standard temperature pressure. Similarly, here we have an example of hydrogen. 1 mole of hydrogen carry mass 2 grams, 6.0 10 to the power 23 molecules in it, and it is equal to 22.414 dm cube, right? For the volume of the nth number of moles at STP, we have to use this relationship. Volume is equal to number of moles multiplied by 2.1414 dm cube. It will give you the volume of whatever the moles are being asked. Now, this is to wind up the lecture today. This is a roadmap of stoichiometry. This will give you different parameters, how they are linked together, what can you get the calculations through this chemical equation. Here we have been given a central equation, a balanced chemical equation, in which reactant A is going to convert into reactant B. The equation presents you the moles of the substances. Now these moles can be converted into grams, and the grams can be converted into moles by using formula on both sides, right? Similarly, moles are related to that of the molar number of atoms or the number of molecules, that when it is related to that of the 6.0 10 to the power 23 particles or the representative particles, or it also gives you a relationship between that of the volume of the solutions when aqueous form they are being used, right? Or it gives you a relationship between that of the standard temperature pressure, the amounts which are given of the gases, right? So the volume taken at this STP is related to the moles of the substance. The conditions once again applied are standard temperature and pressure. Then next one onward is given. This is a simple assignment. Try to do it right on your own and send it to me on the WhatsApp number so that I will check it and return you back.